Hello, and welcome back to the video lessons for Outcome 30.6 on counting principles. In the last lesson, we started talking about permutations, specifically the kind where every object was different. In this lesson, we are going to be looking at permutation problems, where we have a repetition of objects, where they are not distinguishable or not different from each other. So again, our goal is to determine the number of permutations when some objects are identical. Remember, when you hear the word permutation, you should be thinking order matters. Because eventually we are going to get to questions where the order will not matter. So here's our first exploration type question. It said, consider the words bit and boo. Show all the possible arrangements of each word. So again, when they are talking about arrangements, that means that the order is going to matter. So let's start with the word bit. How many ways can I arrange those letters B, I, and T? So B-I-T, B-T-I, T-I-B, T-B-I, and I start with I, so I-T-B, and I, B, and T. There are 6 ways. Now, when I look at the word boo, will I still get 6 ways if it's 3 letters? Well, the first option again is just boo. But if I switch those O's around, I don't actually get any new arrangement. It's exactly the same. So now the next option then is O-B-O. But again, if I switch those O's around, nothing new. Last one is O-O-B, and same thing, if I switch those O's around, I won't get any new arrangement. So in this case, where I had 2 letters that were identical, I only have 3 options. So whenever you have objects that are identical, it's not a straightforward permutation like the last lesson. We have to deal with it in a new way. So to do that, we have a formula. So it says the number of permutations of n objects, where there's A that are the same, and B that are the same, and C that are the same, etc. That is our formula. Our permutations will be the total number on the top, all of them, and then all the ones that repeat or are identical go on the bottom. So by dividing n factorial by a, b, c factorial, and so on, deals with the effect of repetition caused by objects in the set that are identical. It eliminates all the arrangements that are exactly the same and would be otherwise considered multiple times. So we are going to do some examples just to show you how this works. So first example, in the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it, and color is used to symbolize different elements. Green for water, yellow for earth, white for air and wind, and blue for sky/space, and then red for fire. How many arrangements of 9 flags? So that is my n. I have 9 items. Got 1 green, 1 yellow, 2 white, 3 blue, and 2 red. So because there's 2 white, 3 blue, and 2 red, they are identical, I have to use my new formula. So I start with 9 factorial on the top because there's 9 objects. There's 2 white that repeat, 3 blue that repeat, and then 2 red that repeat. So now again, you want to grab your calculator, and you're going to punch it in one of 2 ways. The first way is to go 9 factorial divided by 2 factorial divided by 3 factorial divided by 2 factorial. The other option is to go 9 factorial divided by, and then in brackets, 2 factorial times 3 factorial times 2 factorial, close your bracket. They're both going to get you the same answer. In this case, 15,120. So there's our first example of what we do when we have objects that are the same. All right, here's the next example. How many ways can the letters of the word Canada be arranged if the first letter must be an N and the last letter must be a C? So again, as soon as I see these restrictions, first an N, last a C, I usually do start with my blanks. So C-A-N-A-D-A. I know the first one has to be an N, and the last one has to be a C. Well, the first one has to be an N. There's no other way. It has to be an N. One option. It's an N. Even for the C, there's only one way that can happen. It's a C. Now, what do I have left? I haven't used the A, the D, or the A. I'm dealing with 3 A's and 1 D. So because there's repetition, I have to use that formula. I can't just simply put, if I put 4 and then 3 and then 2 and then 1, that won't work because of the repetition. I have 4 elements and I have 3 A's. And that, if you punch that into a calculator, is 4. So my final answer is the 1 from the N times 4 for the AADA times 1 for the C, giving me a grand total of 4 different ways. One last example. Julie's home is 3 blocks north and 5 blocks west from her school. How many different routes can Julie take if she always travels south or east? Well, there's lots of different ways she could go, right? She could go like that to get to school. She could go like that to get to school. She could go some weird zigzaggy way to get to school. There's many different ways she could get to school. In each of those instances, she always has to go at, for sure, 3 south. And every single time she has to go 5 to the east. There's repetition. There's 3 souths and there's 5 easts. Altogether, making 8 blocks that she has to travel. So if I use my formula, the total number is 8. There's 3 repeating souths. There are 5 repeating easts. And now I have to punch that into my calculator using the one of the 2 methods previously discussed. So if I punch that in, I end up with 56 different ways that she could get to school. Now it is your time to practice.